My name is Mehul Patel, and I've been working in IBM for past 13 years doing some of these hardware validation tools development for the power servers. And in today's presentation, we're going to talk about two very important system development, system test kind of tools, HTX and eCMD. And I have Jason Albert who would cover about the eCMD as well as some of the important announcements about these two tools and how the future of these two tools. So let me start with that. So in the agenda, I have a quick overview of HTX, and then Jason will cover the eCMD part as well as some of the important announcements about the future of these two tools. All right. So HTX, as it stands for Hardware Test Executive, this is basically the system-level hardware validation tool for the power server. So HTX basically, consists of, it's a tool suite, consists of the exercisers. We call it as a test program, call it as exerciser. We have got, in the tool suite, we have exercises for processor, memory, and I/O subsystem. Like, there are programs for VSU, there are programs for L2 cache, L3 cache, memory, fabric bus, a whole bunch of I/O devices like disks, network adapters, RDMA capable adapters, and so on. So the tool suite consists of all these exerciser. Most of these exerciser has got the test logic sitting in the user space, and they're all the user processes. HTX is kind of currently supported on a Linux operating system running either as a KVM guest, or it could be running as a host, or it could even be running as a non-virtualized, in a non-virtualized mode. So currently, HTX is kind of supported and tested on 3 different flavors of Linux, Red Hat, SUSE, and Ubuntu. Each of the HTX exerciser, basically, as I mentioned, the test logic resides in a user space. You could have an associated rule file which kind of describes the test cases, and you can go and kind of change the test cases on the fly, and the exerciser would kind of change its test pattern or behavior accordingly. So HTX also has got 2 different kind of management interfaces to control the exercisers. You could have a menu-driven interface, or you could even have an automation-friendly kind of command line interface as well. HTX has kind of been used within IBM right from bring up to manufacturing test for a little over 2 decades, I would say. And currently, HTX is also kind of available to all the OpenPOWER partners, OpenPOWER members in a binary form. Okay, here's the sort of a high-level diagram of HTX. I cannot go into details of each exerciser, but I just wanted to give you a glimpse of, at a very high level, how does HTX look like. So you can see that on the left-hand side, these are all the bunch of hardware exercisers. These are all basically the user programs. Each of the hardware exerciser kind of runs independent of the other one. And the objective is that each of the hardware exerciser kind of focuses on a specific part of the, or specific unit of the hardware, be it VSU or L2 or L3 cache, or a memory or fabric bus, or maybe an I/O piece over there. These hardware exerciser basically communicates through the bunch of inter-process communication mechanism, and they put in the error logs, message logs, statistics. They feed all of that into an inter-process communication mechanism. And there are a bunch of other helper programs like a message log program or stats program. They basically utilize that information and create some useful files over there. This users basically interact through a top layer, which is called the HTX supervisor. So we got 2 different interfaces. As I mentioned, you have a user interactive kind of a menu-driven interface, or you could even have a command line interface to automate your runs. And as I already mentioned, HTX kind of runs in 3 different modes, where here It can run it as a Linux guest. It can run it as a bare metal, non-virtualized mode, or it can even run on a a Linux in the host environment itself. So with this, I'll hand it over to Jason Albert. He will talk through eCommand. Thanks.
Thanks, Mehul. So eCommand is IBM Systems Hardware Access API for bring up and debug of systems. If you've used the OpenPOWER Lab toolkit, you've used eCommand. And the whole purpose behind eCommand is to provide a consistent user experience when trying to debug the system as you move from system to system or even generation to generation of processor. The core API is a C++ API, but it also provides a Unix command line for debug as well as Python and Perl bindings for scripting. It has, like I said, over 200 APIs, and that's from simple scan and SCOM to I2C access, GPIO access, and even like architected register state in the processor. And there's a core data object that most of the APIs use, and that has a ton of different data manipulation APIs on it. If you want to print your data as binary strings or left-line strings, it provides all that functionality for you. And it is designed so that the user can switch between environments pretty easily. You just flip an environment variable to point to a different plugin, and you can switch from running like the lab bring up debug code to running against the production firmware and their version of eCommand to do. And your commands stay the same when you do that, so your get SCOM, whatever it might be, run the same. And it does, I think we're on like version 14 of eCommand now. It guarantees compatibility within the minor revisions, and it does major revision API checking, just so that way your programs don't core dump. It just prints you a nice, polite message. And it's been in use since 2003, so we've used it on multiple generations of Power now. We'll give you a little bit of a diagram. The eCommand API is the center part here in blue. If you've used, going back to the OpenPOWER Lab toolkit, if you use any of the tools there like FurCheck or IOTK, cron dump, those all run up here in the user space as eCommand programs using the API. And then there's, you can have any number of plugins to talk to your hardware. Cronus is the one people are probably most familiar with. That's what we ship to a lot of people to debug their hardware. There's a plugin layer that you create that'll adapt it to your plugin. So if you have an existing tool, that's what you can use that for. And from a user perspective, it's really pretty slick because if you run a program like cron dump, it'll use Cronus to dump the state from your Power hardware, and it'll create this dump file over here where you can then use eCommand and use the ScanD plugin to go in and do a get SCOM. So whether you're talking to the hardware or a dump file, the user is running the same commands. They don't have to learn for each different tool they move to. So we've kind of covered our test tools and our bring up and characterization tools, which kind of form the core of a lot we do. And so today what we're here to announce actually is that we're open sourcing both of these tools. So IBM's open source, IBM's opened up the hardware, we've opened up the firmware stack, and now we're opening up the tools on top of that that you can use to debug and bring up those things. It's over 35 years of combined IBM development experience in these tools. It's live now on GitHub. It's Apache 2.0 license. And the main reason we're doing this is we want to collaborate with everyone. Mehul talked about the exercisers, and that's definitely something where if you're creating an I/O adapter, consider creating an HTX exerciser and contributing it back. And it is flexible collaboration. We know a lot of people right now, they're using the OpenPOWER Lab Toolkit or HTX. They're using the binary distributions. Those will continue to be available from IBM. If you don't want to mess around with building the source and stuff, you don't have to. But it is available. It is out there. So you can build HTX if you want, and then hopefully while you're in there, take a look, maybe contribute an exerciser. There's sample exercisers that make it really easy to get started. And then same with eCommand. If you feel there's an API missing, propose it. Or at the same point, you can create your own plugin to talk specifically to your hardware. So these two charts, we'll just kind of go over really quick. These are the details, so they'll be online. You can see where to get it from. Mehul is the lead maintainer. Will be the lead maintainer on HTX. And then Matt Light, who couldn't be here, is the lead maintainer on eCMD. And so the documentation's out there for both. We're just getting started. We're certainly, looking forward to feedback on that as well. And so the final slide here is we just want to say thanks. We do want to, like I said, we want to contribute with everyone. With the API defined, now if there's something, I know one of the things that's been missing on the host boot side is no source level debugger. Hopefully now with the API out there defined, maybe that's something that someone's interested in creating. If you've got any questions, find myself or Mehul here on the floor, or get in touch after the summit with the emails there below. So that's what we've got. Thank you very much.